Hi and welcome to this video, Unit Circle and Trigonometry Maths Made Easy. So first of all, we're just going to go over what are called special triangles. So in an exam, if you forget about sine, cosine of an angle, we can work it out using these special triangles. So here we've got an equilateral triangle. All the sides are the same length, unit 2. All the angles are the same, 60 degrees, 3 times 60, 180 degrees. Divide this equilateral triangle into two with this apotherm, which divides it into two. We've got a 30 degree, a 60 degree, and a 90 degree. So this is the half that we're going to use. We put it on its side. When we do that, we get this as the 30 degrees, 60 degrees, 90 degrees. And we want to work out this length, which was the apotherm that we drew. So we can use Pythagoras because we've got a right angle triangle. Remember a squared, which is the hypotenuse, equals b squared plus c squared. When we rearrange that for this triangle, we get 2 squared minus the 1 squared equals x squared, and x equals square root of 3. So this x is square root of 3. And if we use this side as x, this hypotenuse becomes 2x, and this apotherm that we drew, or the adjacent to the 30 degree angle, is x square root of 3. So these are the proportions that the sides are in. Working out the sine, cosine, and tangent now. So we can use these mnemonics. So ka-toa, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So you can write those down in your exam if you don't remember them. So the sine of 30 degrees is opposite over hypotenuse, 1 over 2. Cosine of 30 degrees is adjacent, which is root 3 over hypotenuse 2. Tangent 30 degrees. Now we can do this in two ways. We can have the sine divided by the cosine. So this would be half divided by root 3 over 2. Or we can use TOA, which is opposite over adjacent. So our opposite is 1. Our adjacent is square root of 3. We don't like this root of 3 under a fraction, so get rid of it by rationalizing the denominator. By that we multiply by root 3 over root 3, and this is what we get as the tangent of 30 degrees, root 3 over 3. Using the same triangle, but we're looking at the 60 degrees now. So the sine of 60 degrees, so opposite over hypotenuse, root 3 over 2. Cosine of 60 degrees, adjacent over hypotenuse, 1 over 2. Tangent of 60 degrees, sine divided by cosine, which is root 3 over 2, divided by half, which is root 3. We're looking at 45, 45, 90 triangle. We start off with a square with sides unit length 1, divide it into 2, so we get our 45, 45, 90 triangle. And then using Pythagoras, we get 1 squared plus 1 squared equals h squared, which is the hypotenuse, and the h squared is root 2. If we're looking at this as the side lengths are x, then our hypotenuse is x square root of 2 for a 45, 45, 90 triangle. Sine, cosine, and tangent now. So sine, remember, opposite over hypotenuse. So we're looking at this angle, opposite 1, hypotenuse root 2. When we rationalize the denominator, we get root 2 over 2. Cosine 45 degrees, remember cosine, adjacent over hypotenuse, 1 over root 2. Tan 45 degrees is 1 over root 2 over 1 over root 2, which is 1. So tan 45 equals 1. Remember when we were looking at this 45, 45, 90 triangle, and we saw this ratio of the sides. So the hypotenuse is always the length root 2. So if we're given a question where we're given one of the sides as x, and we need to work out x given that the hypotenuse is 16, we can use that fact that L, which is this length x, or x root 2 equals 16, which is the hypotenuse. And then rearranging, we get x root 2 over root 2 equals 16 over root 2. X is 16 divided by root 2, so x is 16 root 2 over 2. Okay, so remember how we get from here to here. We're doing what we call rationalizing the denominator, trying to get rid of this root 2 as the denominator. And we do that by multiplying by root 2 divided by root 2. Going on to unit circle now. This is another way to remember our angles in trigonometry. So we start off with a unit circle. So here we are, unit circle. Here we've got -1, 1, 1, -1 on the y-axis. This is our diameter of the circle, which is 2. If we magnify, so this is our unit circle magnified, and these are our points on a circle with this radius r. This point here is 1, 0. This point 0, 1. Remember going up the y-axis. X-axis -1, 0, and this is 0, -1. Okay, so those are our points around the circle, which we can get off our graph, which was this one. Okay, that's that magnified. Just as a point of interest, we use radians when you're working with a unit circle. So a radian involves using this radius. So if we take this length radius and then we curve it around the arc of the circle, we get this as 57 degrees, and then the arc, which is this length of the radius, if we do another one, and over here we get, it doesn't reach this 180 degree mark, but there's a little bit left over, and this little bit here is 0.14 r, so 3 r's and 0.14. Okay, does that ring any bells? 3.14, yeah, pi. So 2 pi r is 360 degrees, because that's proportional to the circumference, and where r equals 1, we get 2 pi. So in radians, a circle is 2 pi radians. 1 radian is 180 divided by pi degrees. So for example, pi over 3 radians would be pi over 3 multiplied by 180 over pi, which is 60 degrees. 23 degrees would be 23 multiplied by pi over 180, which is 0.4 radians. So this is how to convert radians into degrees. This is how to convert degrees into radians. So take a little while to go over that. Okay, so in radians, we've got a full circle is 2 pi. Okay, so we go from 0, we go anti-clockwise all around. 360 degrees is 2 pi. So 2 pi, so half of 2 pi is pi. So 180 degrees is pi degrees in radians, or pi radians. Sorry, not degrees, radians. So we're talking in radians now. Half of that again, half of the 180 degrees, 90 degrees is pi over 2. So it's this pi divided by 2. And then here we have 270 degrees as 3 pi over 2. So we've got pi over 2, pi, 3 pi over 2, 2 pi. Okay. So basically we're adding the fractions of pi and then getting on quadrant each 90 degree. Okay, now we're going to divide the 90 degrees into halves, into 45 degrees. So this is 45, 45, 45, 45, 45, 45. So now we've got to go and divide the pi over 2 by 2, and we get pi over 4. So half of pi over 2 is pi over 4. And then we just go in each section is pi over 4. So this pi over 4, 2 pi over 4, which when we simplify becomes pi over 2, 3 pi over 4, 4 pi over 4, which when we simplify is pi, 5 pi over 4, 6 pi over 4, which is simplified 3 pi over 2, 7 pi over 4, and then back here 8 pi over 4, which is 2 pi. So just practice that, so working in 45 degrees, and then where we have to simplify, so here, here, and here. Okay, so those are 45 degrees. Now 180 degrees can also be converted exactly into 30 degrees angles, so we're going to do that here. So these are our 30 degrees, 30 degrees, 30, 30, 30. So there's 1, 2, 3, 4, 5, 6 30s in 180 degrees. So what we do is divide pi by 6. So this here is pi over 6. This is 30 degrees, it's pi over 6. Then we go up in adding each pi over 6. So this would be 2 pi over 6, which is pi over 3 when it's simplified. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3 when we simplify it. 5 pi over 6. 6 pi over 6 when we simplify is pi. 7 pi over 6. 8 pi over 6 when we simplify becomes 4 pi over 3. 9 pi over 6 simplified, 3 pi over 2. 10 pi over 6 when we simplify becomes 5 pi over 3. 11 pi over 6, and then finally 12 pi over 6, which is 2 pi simplified. So we always use the simplified fraction of pi, or in this case the whole pi is 2 pi. Okay, so those are our 30 degrees and our 45 degrees. So 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and back to 360 degrees. So these are our radians, and these are our degrees. Okay, now we're going to look at sine and cosine. So if we had in our unit circle 45 degrees here, which is pi over 4, this length up to here is our cosine. So along the x-axis we've got our cosine, and this length, which we can translate over here to our y-axis, this length up to this point here is our sine. So along the y-axis, sine, along the x-axis, cosine. Remember x, y? So x would be cosine, y would be sine. Now using our 45, 90, 45 triangle, we get this cosine and sine as root 2 over 2 and root 2 over 2. So this is the cosine, this is the sine, x, y. Now if we have a look at the other angles, so we've just done the 45. If we had a look at the 30 degrees from our 30 degrees triangle, we get our x value, our cosine value is root 3 over 2, and our sine value is half. So root 3 over 2 and a half. Similarly, our 60 degrees, cosine 1/2, sine root 3 over 2. And we discussed these values as before, yeah? So this would be 1, 0, and this would be 0, 1. So we go along and fill out all these values now. So how do we get, so we've done this quadrant here, which is called quadrant 1. So now we'll go to quadrant 2. So quadrant 2, if we look at this sine and cosine values, they are the same because it's symmetrical. Okay, so this value, ignore the minus for now, is a half root 3 over 2, and for 60 degrees here, a half root 3 over 2. So it's like we've got some symmetry going on here. If we folded it along this y-axis, we folded the circle. The only difference is now that the cosine, this x value, is negative. So we're going in a negative direction here. Sine is still positive, cosine is negative. So we've got to put a little negative here before the cosine value, the trig value there. Okay, so it's minus a half as the cosine, but the sine is still positive. So now we're going to this quadrant 2 and label all those. So remember, don't forget the negatives. So this is the same as this. This here is the same as root 3 over 2. Is the same as this one over here. It's 30 degrees, except we've got this negative on the cosine. And then when we go into quadrant 3, which is down here, again, we use, it's like a symmetry across the x-axis. So this one goes down here, half root 3 over 2, and this one goes here, and this one here. So we're just doing like following it around. So better to practice that and see if you can get the hang of it. Yeah. Here we're just going to concentrate on this quadrant here, quadrant 1, and just see if we can remember those, because it's from this one quadrant that we can sort of go and put in the values for all the other angles in the circle. So if we'll have a look at this, this and this for 60 degrees, 45 and root 3, the way I like to remember it is put some expanded brackets and then put at 30 degrees 1, 45 degrees 2, 60 degrees 3, and then going the other way 1, 2, 3. So put those in like expanded brackets, and then put all those 1, 2 and 3 over 2, over 2, over 2, over 2, over 2, and then square root the top. So when we square root 1, we're just left with 1, square root of 3, square root of 2, square root of 2, square root of 3, square root of 1, which is 1. And there we've got our values for cosine sine 60 degrees, cosine sine 45 degrees, cosine and sine 30 degrees. Okay. Just what we were talking before, when we're labeling the different quadrants, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, and which value is positive and which value is negative in which quadrant, we remember using what's called cast. So C-A-S-T, cast. So in this quadrant, which is quadrant 4, only cosine is positive. Quadrant 1, all are positive, so both cosine and sine are positive. Quadrant 2, only sine is positive, and quadrant 3, only tangent is positive. So that's another way to remember which is positive and which is negative in which quadrant. Unit circle we can use to work out exact values of trig functions. So for example, if we want the exact value of the sine of 300 degrees, so 300 degrees when we go around from 0 lies here, we use what's called the reference angle, which we measure from x. So it's the acute angle from the x-axis, which is here, which is 60 degrees. So remember, this is the same as this in our unit circle, gives us the same sine and cosine. So the sine of 60 is root 3 over 2. So we want the sine of 300, which is the same as the sine of 60. And then look at the quadrant and what is positive and what is negative. So the sine of 300, and we know that in here only cosine is positive, so the sine is negative. So sine 300 degrees is minus the sine of 60 degrees. Quick way of remembering sine and cosine: 1, 2, 3, 1, 2, 3 for 35, 40, 30 degrees. 1 over root 2, root 3 over 2. Sorry, 1 over 2, root 3 over 2, root 2 over 2, root 2 over 2, root 3 over 2, 1 over 2. So that's like, you can do that in your scratch work if you're in an exam. The exact value of 225 degrees, we've got to evaluate that. So 225 degrees when we're going round from the x-axis this way, anti-clockwise, it's here. So the angle we're interested in, our reference angle, is 45 degrees. Measure that, the acute angle from the x-axis. So that's the same as this in our unit circle. This is our reference angle, 45 degrees. So this is the same as the cosine of 45 degrees. So remember here, CAST, only tangent is positive, so the cosine will be negative. So that would be minus 2 over 2. Okay, so we've done that there. We had to rationalize the denominator. And this is how we do that. 1 over root 2 when we're rationalizing. We multiply root 2 over 2, which is root 2 over 2. Similarly here, if we're given it in radians, evaluate sine pi over 6. So pi over 6 is here, which is a reference angle from the x of 30 degrees. And it's a half. So the sine of 30 degrees is a half. And in quadrant 2, sine is positive. So remember CAS, sine positive. And so the answer is half. Sine 5 pi over 6 is a half. Evaluate tan 4 pi over 3. So 4 pi over 3 lies here. This is our reference angle that we're going to use, this 60 degrees. And then for 60 degrees we've got tangent sine over cosine as a half divided by 3 over root 2. And that gives us the tangent as root 3. So here we've done root 3 over 2 multiplied by 2 over root 1, which is the tangent, so that's the sine divided by the cosine. Okay, sine divided by the cosine. So it works out when you divide, we multiply by 2 over 1, and we get root 3. Sometimes we have to use trig identities to work out our exact angles. So these are our trig identities: sine A plus B equals cos A cos B plus cos A sine B, cos A plus B equals cos A cos B minus sine A sine B, tan A plus B equals tan A plus tan B divided by 1 minus tan A tan B. So if we want to work out the sine of 15 degrees, so that's exactly the same as sine of 45 minus 30. 45 minus 30 is 15. So we can use this trig identity, but here it's a minus, so this would be a minus here. So we'd have sine 45, this A, cos 30, this is B, minus, because we got the minus here, cos 45, sine 30. So we're using this trig identity, but with the minus and a minus there. Put in our values, and we get sine of 15 is 0.259 when we do this calculation on our calculator. Similarly, if we got sine 5 pi over 12, so instead of given in degrees, we're given in radians. So that's exactly the same as sine 3 pi over 12 plus 2 pi over 12. And we can work it out in this way, which is sine pi over 4 plus pi over 6. And then we use our sine A plus B rule, which is here. And we get pi over root 6 plus root 2 divided by 4.